my dear students, welcome back to my class. In the series of learning programming in C, in the previous video, we have learned about different types of recursion. Direct recursion, indirect recursion, tailed recursion and non-tailed recursion. In today's video, we will discuss about call by value or what we call it as pass by value and call by reference or pass by reference. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. If you like the video, please click on the like button and share the video to all your friends. So what is this call by value or pass by value? So we have seen how to call a function or how to pass the argument to a function. We know what is actual argument, what is formal argument and what is function call. We have dealt this in the previous videos. Please do check out the playlist. And call by reference, value and reference. These two difference we need to know. Value means what? The actual value that what we are going to pass. But reference is nothing but address. Reference means address. So when I call a function, I can pass the actual value itself. Then it is called by value. When I call a function, I can pass the address of the variable. That is what? A reference. Why we need to pass value and why we need to pass the address? Let us understand that with an example program. So let us understand this call by value method or pass by value using this simple program. So here I am just trying to swap two values. Swap means interchanging two values. Call by value means calling the function by passing the actual value, or what we can call it as pass by value. Call a function by passing the actual value. Where do we pass the actual value, the actual argument? We pass that in function call. So these things we all have studied in the previous program set. So this is function header or what we call it as prototype. This is function call and this is what the function definition. This is what the complete calling function and this is what the called function. And here I am passing the actual arguments. This is what the actual arguments and these are the formal arguments. Well, in the declaration itself, that is in the prototype itself, we can have the variable name, then I can call them as formal arguments. Or else wherever we have the variable name in the definition, we call them as formal arguments. Well, so the function name is swap. It is taking two arguments, either of integer type and return type is void. This is what the declaration, semicolon is there, and this is what the main function. So I have declared. So as soon as the compiler encounters a variable declaration, come initialization, memory will be allocated for A and B. Say some address, say this is 100 and this is 200 and the value initialized is 10 and 20. Right. Now I am calling the function by passing the actual argument. So pass A and B means A is carrying 10 and B is carrying 20. Actual arguments. As soon as the function call is encountered, the control will be to declaration and then to definition. Now I have the formal argument AB again. Don't get confused. AB is local to this calling function or to this main function and AB is local to this subfunction, means the compiler is going to allocate new memory for this A and B. So A and B are new variables of this subfunction. It is nowhere related to A and B of main function. AB is different there in the main function and AB is different in this main subfunction. Main function and subfunction. If you get confused, you can just have the variable name as X and Y, some other variable names. Okay. Now, I just gave A and B just to make you understand that AB is different here and AB is different here. That's why I have used the same variable names here also. Okay. So I say A and B. So the address is some address I'm writing 300 and 400 just to make you clear that A is different and A is different here. A is local to this main function and the memory is 100, and A is local to the subfunction and the memory is 300. And B is different. Say A is receiving 10, actual value I am receiving means to say the copy of A I am receiving in a new variable of A in subfunction, so it is receiving 10, and the copy of B, which is 20, is stored in this formal argument B, a new variable B in the subfunction, so it is 20. Okay. Now a local variable temp is used so that I can do the swapping of these two values. I say A value to temp, a copy of A in temp. So it is 10. Store the value of B to A. Assignment operator, how it is going to work, you all know. So B value to A. So whatever value I have in B, that will be, a copy of that will be stored in A. So now this becomes 20. A becomes 20. Then whatever value I have in temp, I am storing it in B. Temp is having 10, that will store it in B. Now 10 is in B. So A and value interchanged. A, B values are interchanged, and this is to this subfunction. And I am printing the value of that. So in my output screen, I will get the value A equal to interchange value 20 tab space, B equal to 10. After executing all these statements, the control will be back to the place where the function was called. Then the control to this statement. Then I say print if A equal to percentage D, B equal to percentage D, print the value of A and B. Now what is the value of A and B here? A is different and A is different here. A is having 10. Now in my main function I am getting A equal to 10 and B equal to 20. So whatever changes I did in the called function is not reflecting back to the calling function. This is what the drawback of the call by value or pass by value method. The changes that what I do in the called function will not be reflected back to the calling function, and I'm simply wasting the memory here because I'm passing the actual value, so I have to receive that with new variables, with new formal arguments. So when I'm receiving that with new formal arguments, new variables, so whatever changes I'm doing with that new variables, not with that actual variables. So whatever changes I do, it is to this subfunction. So it is to the local variables that what I have here, A and B. So here the values are swapped. When the control is back to the main function, and if I say print the value of A and B, A is having 10 and B is having 20. This is what call by value or pass by value method. So here we have the program for call by value. So we have the function as swap, two arguments of integer type. In the main function, we have the values A and B initialized to 10 and 20. So let us print the values of A and B first so that we can know what is the original values. Then the function call encounters. Then the control will be to definition. A swapping code is written here. Then the control will be back to this place. Then I'm printing the value after swap. So here AB values get swapped, and when I come to the main function, I should get the swapped values. So let us see that now. Save, control F9. Values before swap, A is 10 and B is 20. After swap, in the main, I'm trying to print the value of A and B. So it is again 10 and 20. It has not been swapped. Why? Because look at the variables. AB is the actual value I'm passing, and I'm receiving that with formal argument AB. See, again it is AB, but AB is local to this main function and AB is local to the subfunction. Means to say, A is a new variable that is receiving this value 10, and B is a new variable that is receiving the value 20 in subfunction. So whatever changes I do here in the subfunction, it is to the subfunction only. After doing the changes, when I get back to main function, here if I just try to print the value of A and B, it is AB of this main function, which is 10 and 20 itself. Right? That is what we got. So what I'll do here, let me try to print the value in the subfunction itself. Then I'll get the value of AB, which is swapped. Now save this. See, when a function call encounters, the control will be to this part. Values will be swapped, and swap value also I am trying to print. Then again the control will be back to this place.
then these statements gets executed. Print the value of AB means it is 10 and 20 only. Okay, let us see that now. Okay, save, control F9. Yes, see here. Values before swap 10 and 20, then function call. Values after swap in function, see here. A equal to 20 and B equal to 10. Swapped values. Then again control back to main function. After swap in main means what happens with A and B? A, B value, that whatever I have in the main function, that value itself gets printed 10 and 20. So whatever changes I do in the calling function, that is called function, is not reflected back to the calling function. This is calling function, then this is called function. Whatever changes I do in this called function is not getting reflected back to the calling function. Called functions, I did some changes. AB value got swapped with this code, right? So in this called function, whatever changes I did, that will not be reflected back to calling function. If at all, if you want to have that kind of changes. And one more thing, the new variable is receiving that. Memory is getting wasted. Values are not reflected. So how to overcome this? We have to see call by reference. How to have the reference, that is address, that we'll see in the next video. So stay tuned to my channel. Okay. So we will have the content of call by reference in the next coming video. That's all for today's video. See you in the next video. Till then, take care. Bye bye.